So here I have some distilled water, and here I have some calcium metal, which is an alkaline earth metal. Let's combine them. Now first, I have some pH strips here. And pH strips are pretty straightforward. We dip them in something and they change color based on the pH. So I'm just gonna take some of the distilled water, get my pH strip wet. You can see it didn't really change very much. It's right around a 7-ish. Okay? So put that pH strip there. Now I'm going to add some calcium metal. Now you might be able to see it from there, but it's slowly giving off little bubbles. You see little bubbles forming as it reacts with the water. Like I said, calcium is an alkaline earth metal, so it doesn't react as violently as the alkali metals, but it does react with the water. As the calcium reacts with the water, it gives off more and more bubbles, and the water starts to become cloudier. You can see it's getting more and more cloudy, and it's harder and harder to see the actual calcium deposits at the bottom. It's all becoming one murky mess, a murky solution. The gas being created here is hydrogen gas. You can see there I lit my lighter and then I bring it next to the bubble and it catches fire. That's because it's hydrogen gas, which is flammable. So now our reaction is just about complete. Now if you remember, this is the pH strip from before. Focus. So we're about a 7, not quite an 8. Now let's try mixing this in here. You can see that it turns a bluish color. Blue indicates that an alkaline or a base is present. So this one's probably right around 12-ish, I would say. Focus, camera, focus. So about a 12 pH. So the pH changed quite dramatically. The new substance we've formed here is calcium hydroxide. The calcium reacted with water and created something new. Here we have the equation for this reaction. Calcium, which is a solid, plus 2 molecules of water, which is a liquid, we use the cursive L so you can tell what it is, makes calcium hydroxide, and we put AQ because it's in an aqueous solution or in water, and hydrogen gas. So calcium plus 2 waters makes 1 calcium hydroxide and 1 hydrogen gas. Hydrogen gas is flammable. You know that whole Hindenburg thing? It makes a big boom if you have enough of it. Calcium hydroxide has a lot of uses, one of which was in pickling. It's something called pickling lime. You may have heard of it, you may not have, but they would dip the pickles, or whatever they're doing the pickling process to, in the calcium hydroxide, and then they'd put it in the acid bath and it would give the pickles a nice crunch. The problem was if people didn't fully rinse off the calcium hydroxide, then when they put it in the acid bath, it neutralized the solution. And when you neutralize the solution, it's no longer acidic by definition. And if it's no longer acidic, it can no longer kill bacteria, which is the whole point of having an acidic solution. So people started to get botulism, and that's awkward. Big whoopsies there. Now, I've been talking about food grade calcium hydroxide. There's also industrial grade, so you want to make sure you don't mix up the two. Industrial grade, if you accidentally ingest that, it could lead to calcium hydroxide poisoning, which has a lot of symptoms ranging from skin irritation to vision loss to vomiting blood. So that's awkward. Don't ingest that. But don't worry, you're not going to get any problems from having pickles or sugar or anything like that. And you can keep eating those if you want. I personally won't be eating any pickles because I think they taste like feet, but that's just my opinion. You do you, man. They're still beeping. People started. Here we have the hydrogen gas is flammable. You know that whole Hindenburg, boop, boop, boop. they would dip the pickles in the calcium hydroxide, and it would get, and then they'd be, hydroxide is a piece of garbage sauce.